Welcome. The next topic that we're going to discuss under the domain of concentration is mass percent. As I said, the idea of mass percent can take more than one formulae. So I've given you a very generic one, okay? Mass of component one versus total mass of all components, okay? The mass could actually be your regular mass, like 25 grams or 30 grams or whatever, or it could be molar mass, okay? The mass here is very generically stated. It could just mean mass, or it could mean molar mass. So you've guessed it, yes. The problem we're going to actually do involves molar mass. How do I know when to use mass or molar mass? Just don't think. It's just that simple. Well, to actually give you a clue, you don't see any numbers here, do you? Do you see any numbers? All right, that means the mass here literally refers to molar mass. So without further delay, let's actually calculate the molar mass of this compound, and then we will get into actually solving the problem on how to do mass percent. Okay, aluminum's molar mass is about 27, so it's 27 times 2, okay, plus 3 times sulfur is 32, plus 4 oxygens, each is 16, so that's 64. If you add this all up, you're going to get the total molar mass of this compound. So that's 54 plus 3 times 32 plus 64. That's 342 grams over 1 mole. Okay. Now the question is asking mass percent of each element. How about I do a couple and then you do the last one yourself? All right. Now, I've already explained how to read the transcripts, right? Here, this compound contains 2 aluminum, right? This 3 does not carry into the aluminum. That's only for what's within the brackets. So that's 3 sulfur and 12 oxygens. So how about we start with the difficult one of the pile, because people might generally think, oh, the bigger the number, it's going to be difficult. There's no such thing. So let's calculate the mass percent of oxygen. How do we do it? Well, we got 12 oxygen, right? So the total molar mass here refers to total molar mass. So we're going to put the 342 on the bottom, over 1 mole. Don't worry about it. This whole thing is one thing. And then we got 12 oxygen, right? So each oxygen is 16. So it's 12 times 16 is, again, I'm using the molar mass of oxygen. That's 192 grams over 1 mole. Okay? 192 grams over 1 mole. This whole thing is multiplied by 100 because it's percentage, right? Now keep in mind, this is simply same as writing 192 over 342 times 100. Why? Because the units are exactly the same. So in a nutshell, what that means is 192 divided by 342 times 100 is 56%. That makes sense, right? Oxygen seems to be a major proportion of this compound. So let me do it for aluminum, and you guys can do it for sulfur, okay? So I obviously won't make it on this video. You have to figure this out yourself. So let me do it for aluminum. Each aluminum is about 27, so 2 times 27 is 54 grams over 1 mole, right? So mass percent of aluminum would be 54 grams over 1 mole. This is one single unit divided by the total, which is 342 grams over 1 mole, and this whole thing multiplied by 100. So that is essentially same as 54 divided by 342 times 100 will be 54 by 342 times 100 is 15.7, roughly about 16%. Okay, good. Now, I want you to figure out the mass percent of the only element that's left is sulfur. Now, the trick here is this. You've got to do this, then the whole problem becomes easy. Now, in this case, I'm kind enough to give you the actual formulae, but what if I didn't? Well, what if I say, let me say the same question, so I'm going to write it, determine mass percent, okay, of each element in titanium 2 or 3 oxide. Let's see if we can do this. Keep in mind, I have actually not solved for sulfur. So you're going to solve that, calculate the percent, and then you would determine also the mass percent of each element in titanium 3 oxide. This is a case where I've actually given you the name and not the formula. See if you can do it. And then if you have questions, you can ask me. All right, so we're going to move on to the next concentration unit. I believe that is mole fraction. So stay tuned.